Today we're going to cover a lot, so I'm going to try to roll through everything sort of fast. We're going to work on sound reactive visualizations to prepare us for project 3 and showing off work in a professional venue in a live event. We're using the P5JS sound library, so in your HTML document, make sure you have this script with the source that has p5.sound.min here. And I have version 1.10.0. We'll set up our sketch from the ground up, more or less, although I have a couple of functions. Ooh, that's cool. Functions here that I'll show you in a sec. But we'll do create canvas, window inner width, window inner height. You don't need window dot, you just put inner width or inner height if you would like. Draw a background, change the color mode up in the setup function to HSB, hue, saturation, and brightness, so that normally the default is RGB. You can do around 200 is a blue, 100 saturation, 100 brightness. And let's right click our index, open with live server. If you don't see this, then you can go to the extensions and type in live server and then add this to your project. Cool, so I have my project here so far. First step, with this project, we have to have a ratio set up. We're gonna be using the 4:3 ratio because that's the projector size that we'll be working with for our project. So say, create a couple variables. So at the top, we'll do let ratio equal 1.333, and this, or 3333, you know, just a ton of threes. That is the 4:3 aspect ratio. And in order to make that work, you just have to say create canvas. You've got inner width, but in inner height, instead of saying inner height, we're also going to say inner width, and we're going to divide it by that ratio variable that we made, so that when we save it, you can see that it snaps to that size. The other thing that I want us to do for this project, now that we're using ratio, is to create a globe scale variable. So this is going to be our scale factor, and we're going to use it instead of using multiplying by height or multiplying by width. We'll use globe scale. So this is going to keep consistent scalability based off of our ratio throughout, like, no matter where this is being displayed. So just do it and you'll thank me later. So we'll set globe scale equal to, use the min function, and it'll be width comma height inside of that. And this is just selecting the whatever's the smaller one. Is it width or is it height? Whatever's smaller, that's what globe scale is going to be. So the smallest variable, or the smallest size, will be our globe scale, and then we'll multiply all sizes in our sketch by globe scale. Let's add something here to our sketch real quick. I have created a smiley face function, and I just created smiley.js over here, and I put my smiley face function inside of it. This allows me to keep my code a little bit more manageable and readable, and feel free to just like copy paste this over to your sketch while you're following along. Here it's really simple. It's just drawing a face, drawing eyes, and drawing a mouth using the ellipse function here. So face has an ellipse, draw eyes has 2 ellipses, and then draw mouth is just using the arc function here. So the arc function has like a bunch of parameters inside of it, like mouth x, mouth y, mouth width, mouth height, which is what I'm calling these things. And you can see up here that the face diameter, so the total size of the smiley face, is using globe scale here. And then the eye diameter is using face diameter. All of this stuff is using face diameter. And if face diameter is using globe scale, then all of this stuff is also using globe scale as well. I want to say that you see mouth Y and mouth X here, and then the X and Y locations here. The X and Y locations will still use width and height. The only thing that we're using globe scale for is the size of things. So keep that in mind. Back into the sketch, we will draw our smiley face function by calling it draw smiley face, and that's what it looks like. Haha. Also, in order to use this function, you have to, in the index.html here, you have to, under the sketch.js, attach the script in the body here. So you can just like, what I normally do is I copy and I paste, and then I just change the name, and the name has to be the same name that is over here. If you don't have this, it won't show up. Back into our sketch, next thing we need to do is grab audio input. So we will be visualizing sound. So we need to capture that sound from the microphone on our laptop or whatever mic is attached to our laptop or our computer, right? The way that we're gonna do that is up here, we will create a couple of variables, microphone and volume. The mic will be the mic input, volume will be the amplitude, so how loud or how quiet something is. We'll set mic to equal new P5 audio in. So this is a P5 object that just captures a bunch of different things. And if you come down here and you console log that mic variable here, you could save it and press F12 or open up the DevTools, and you see here you can like click this, and there's like a whole bunch of stuff that this audio in object contains. In order to start that input, you need to do mic.start. From here we can use the volume. So in the draw function, we'll say vol equal mic dot get level, and then instead of logging this mic, we can now log the vol. Whenever you do this, because we're using the browser, you're gonna have to like allow access, allow while visiting site maybe. And here you see that we've got a bit of an issue. So when we're not using audio, the audio context was not allowed to start. It must be resumed or created after a user gesture on the page. Normally I say ignore it, but if we need audio, now we have to pay attention to this alarm. Start after a user gesture, we really just need to like click in and be able to have it start. So we'll create a Boolean called start audio and set it to false. And then in the draw, we'll just wrap everything in an if statement. So if start audio, add a closing bracket down at the bottom. If start audio, then everything here will do its thing. And then we have to make a function called mouse pressed, because that will act as our user gesture to start the audio. And we'll say if not start audio, so if if it's set to false, then we will put this audio in stuff in this statement here, and Alt-Shift-F if you want to clean it up. So if start audio equal false, which it does start at false up here, and the mouse is pressed, then we're going to grab that audio input and we're going to start the mic, and then we are going to set start audio to true, And then once start audio is true, then all of this stuff can happen. So first step, click on the page, and now we see a whole bunch of numbers popping up because it's reading all of the audio input from the mic all the time. Make sure you have your if start audio. Really, we only need to wrap this inside of this if statement because we don't really have to, we can like show the background and show the smiley face. So I'll take this closing bracket and I'll just wrap it around my volume. That way we can actually see it, and then we click and boom, it works. We need to do something with this vol variable. So what do we want to do? Well, I want to make my mouth move. So I'm going to go into the smiley face function, and that vol variable, go to mouth height is the size of this mouth here, and if we go up to mouth height and maybe change it, you can see it gets smaller. So I want it to start at this here, and then in the arc function where mouth height is located, I will just multiply this by our vol. Oh, hello. It's not reading because we have to like click in the sketch at the top whenever we create our vol. Let's actually delete that and say let vol equal 1 for right now. So that'll be like our starting value. If we set it to 0, it would be multiplying the mouth by 0. So you need to set it to 1. So why isn't it doing anything? Well, you see these numbers down here in the console? They're very low. It's 0.01, 0.02, right? You can see that they're changing, but they never really get above 1. I mean, we could try it. Hello. If we talk really loud, it'll go to 1. But get level only returns a value between 0 and 1. So this is the moment where we need to sort of scale up that volume. Here under volume, norm vol equal volume times vol sensitive. Or maybe we'll just say, to shorten it, vol sense. So this is going to normalize the volume, and it's just like scaling it up. So vol sense, it could be any number that we sort of define. So volume times whatever vol sense is going to be like this really tiny number, 0.1 times whatever we make vol sense. So it'll scale it up. So what's happening with the mouth is it is actually moving, but it's only moving at a scaled factor of like 0 to 1. So if we like multiply that by, let's say 500, let's see what happens. Set vol sense up at the top here. All right, we'll put it at 200 for volume sensitivity. So this is going to be the way that we create our threshold meter. And everybody has to do this in the class because this is how we're going to make our sketches work in real time during the live performance. So it's very important that we do this and we understand it. So norm vol now equals volume, get level, times 200, right? So now in order for this to work, we have to go back into our smiley face. So I'm going to save that, go to my smiley, and here, oh, I already put it, but change vol to norm vol. Let norm vol equal 1. So we just need to click in now, see what happens. Oh my gosh, look, we get to 0. I have no idea why it does this sometimes. Hello. It's so strange. Sometimes it works, sometimes it doesn't. Let's set norm vol. Let's take away the 1 here and just test it. hello, hello. Okay, so it's working now, as you can see. The scale factor is pretty large, right? So we can change that. So we can like change it to 100 and then press in. Hello, 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 hello. I am smiley. That works, right? And now I have a face to the voice, which is kind of cool. So let's see, what else do we need to do? So I figured out that problem, even though we have this mouse pressed function that is supposedly supposed to start the audio, for whatever reason, it's still fumbling. Up at the top of your sketch, go ahead and put in get audio context dot suspend here. And this is a P5 function. And so you're going to suspend the audio context, and then we're going to use another P5 function in the mouse pressed area. So instead of doing all of this stuff, we're just going to say, actually we can keep this here because it really, it doesn't matter. But we'll also put a function called user start audio, and let's see if this works. It's supposed to work with P5, but I've never used it in VS Code. So next I want to create a slider that changes the sensitivity level so that we don't have to actually go into the code to change it. It can just be a part of the interface that we use during the live performance. And so here in the P5 references, there's a function called create slider that we're going to use, and a lot of you in the class have already used it, so you'll be familiar with this. I'm going to say let vol sense slider, and then create the slider. And what are the parameters? If you scroll all the way down, you can see here that there's a min, max, and then value and step. So min is the minimum value of the slider, so 0 would be a good value. And then let's see, we've got 100, so let's set our max value to 100 here. And then this one is the default value of the slider. So the default value should be vol sense. So actually, if the default value is 100, let's just make the max value like, I don't know, twice as much. So vol sense would be in between the min and the max. And step is the size for each step in the slider's range. So this is optional. Slider step might be a good thing to have. Let slider step equal 10 for right now, and we can always change that later. So it starts right in the middle at this vol sense. And if we move it up, it would increase by 10. So it would be 110 rather than 101, 120, right? So hello, hello, hello. So if we put it all the way down, hello, hello, uh-oh, hello. Oh, and it's not working because we forgot one more thing. We have to set vol sense to the slider value. So down here, we can just say vol sense equal vol sense slider dot value, and let's see if it works. Hello, 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 hello. It works pretty well. So this is perfect. See, like, okay, now I'm talking like kind of loud, and if I'm talking this loud, maybe I want to like turn down the sensitivity. But if I'm talking really quiet and I need to see more action, maybe I want to turn it up, right? So this is going to be super duper good for us, and we all have to have this slider, okay? We'll create a variable called FFT, And this stands for fast Fourier transform. And here in the P5 references, FFT is an analysis algorithm that isolates individual audio frequencies within a waveform. Once instantiated, the FFT object can run an array based on two types of analysis. So you could do waveform, computes amplitude values along the time domain. We've got FFT analyze, computes amplitude values along a frequency domain. Correspond to frequencies, so pitches. So this is going to be nice because I want to use pitches from lowest to highest that humans can hear. Each value represents amplitude at the slice of the frequency spectrum. So use with get energy to measure amplitude at specific frequencies. Down here we can see an example. So this is literally visualizing frequencies. So that is what we want. So step 1, we made a variable called FFT. And then step 2, similar to the way we did this mic audio in, we'll just come down to that, and underneath the mic object, we'll say FFT equal new P5 FFT. Next, we will create a variable called spectrum. And this will be the frequency spectrum. And if you come over here, you can see that they have spectrum set to FFT.analyze. So analyze the frequencies, that's what we need to do. And we'll put this, since this is sort of like analyzing the, similar to what we did with analyzing the volume, I like to put things that are similar next to each other. So I'll just say spectrum equal FFT.analyze. So this is the waveform that we were looking at, which the waveform here, if you look over here, is this line right here. So if you want to create that line, then here, let me pause that. Then you need to look into this. And maybe you want to, you know what? I've never actually used waveform, so I think I want to play with it this time around, because I've done this before, but I've never done this. So let's do that. Let's create a waveform variable, and then here, and we can always use spectrum later. Say waveform.fft.waveform. Go ahead and just copy this from no fill to in shape, and I'll describe what it is. And it has to go in if the audio is started. All right, so I sectioned off our waveform visualization, and the no fill is because we have this begin and end shape here, begin and end shape. This is creating a custom shape instead of using like the function ellipse or whatever, or rect, right? You can use this begin and end shape, and you can actually like draw out various shapes using vertices. So you see here that there's the vertex function, and it is using X and Y. So here X is using the map function, and we've got the waveform.length, which we could always, it's using FFT. So it's using the waveform link from FFT, and we can sort of uncover how long this is if we console log it. But let's just save that for later, and I++. So this is like reading through this FFT waveform here, and it's like reading through all of the frequency bands, I'm pretty sure. And then it is mapping X along the X axis, right? To the waveform lengths 0 to width, so that it's like constrained within the canvas width. And then Y right here is mapping the waveform array. So maybe Y is, okay, yeah, Y is the thing that is you know, doing like the real time frequency band change. And we'll look at that in a sec. So -1, 1, 0 to height. So it'll always stay constrained within the height of the canvas. And I guess -1 and 1 is, I'd have to like look more into this as to what the -1 and 1 is, because this is the first time I'm using waveform. We may be missing one last thing. In the mouse press, here under FFT, say FFT dot set input to the mic. So it knows that it's grabbing from the mic object. And let's try it out. And whoo, hooray! Hello! 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 Ah! Okay, it works. That's awesome. Okay, so to tidy up some stuff, I'm going to take our waveform visualization, do Control X to copy it, and just do, I'm going to create a waveform function. So this can be a little bit cleaner in our draw, and I'll just put the waveform function down here. Oh, and then just make sure you do if start audio down here. So and make sure you capitalize this. If I'm going to capitalize it down here, I have to then capitalize it up here. And hello, hello. Okay, so it is functioning. Cool. And the reason why I'm doing this is because I'm just going to really quickly add in not just the waveform, but I'm going to use our spectrum here too. So in our spectrum function here, we'll just do something sort of similar to what they've got going on here with their bands here. And you can just see they're reading through the spectrum length, and they are mapping the X to the spectrum length, and then we've got the height here. So for me, it's going to look a little bit different. So if start audio, create a for loop, let I equals 0 if I is less than spectrum.length, then I++, and it did that automatically, but I'm going to get rid of it. We actually already have a variable called spectrum, so I have to change this function name here. So let's just do spectrum F for function. Just follow along with me here. We'll do no stroke, and we'll do fill. And I want to fill with the hue of the hue will be my spectrum array, and saturation 100, brightness 100. And then I'm going to create a rectangle, a bunch of rectangles actually. And the way that I do a bunch of rectangles is on the X location, or depending on like where you want to draw this. I just want it to be, for right now, from the left to the right, I'll make the bands occur. And so on the X axis here, we'll put rect X. Rect X will be mapping the I value, which is 0 to spectrum length to 0 and width. So this keeps the rectangles in the width of the screen. And then whatever we want rect Y to be, so rect Y, it will be here at the bottom of the screen, so that's going to be the height of the canvas. So I'll say rect y equal height, and then put rect y here, and then we need a rect width and a rect height. So our rect width will be dependent on globe scale. We'll just put maybe 0.05 for right now and see what that looks like. And then rect height will be linked to, and it actually did it here. So we're gonna map rect height here. It's saying 0 to 255, which I would need to verify, but I'm gonna assume that's correct. And then 0 to height. So it's going to map 0 to 255 to 0 in height. So if the spectrum is at 255, then the height of the rectangle is going to be all the way up, to the length of the canvas. And then we've got a negative here because this is going to make it, if you recall, like 0, 0 happens here and it increases on the y-axis as it goes down. So we have to do negative so it'll go up instead of down. If we don't have this negative here, then we're not going to see the bands anywhere on canvas because they're going to show up like below the canvas down here. I played the sketch and we are getting an error. Oh, because I called it spectrum visual up here instead of spectrum F. So I'll do an F. And hello. So cool, now we have multiple things happening. We've got the amplitude, we've got the waveform, and we've got the hello, and we've got the frequency bands here. Let's play around with the bands a little bit more and add a little alpha value to the fill at 0.1. Hello. So it looks kind of like a little bit more seamless. It's kind of nice. We could even bring down the background up here to 0.1. And let's see what that looks like. Hello. So we've got some tracers happening now. So already we've got a slightly more interesting composition. And then say maybe I want to like reflect these bands on towards the right? Like I want to have like a Rorschach thing happening around my smiley face here. Well, let's figure out how to get that going. We can just go down here and copy this rectangle function. And instead of rect x, gotta create a rect x2 needs to equal we have to reflect it across this location, right? To get it to start here and to then go this direction. So we'll just say we wanted to start at width minus rect x minus rect w and see if that works. Hello. Very fun. Cool. So yeah, we're getting somewhere. We've got some cool visualizations happening, and then our little, we didn't scale this guy very well yet, but we'll do that later. Okay, let's dive a little bit deeper into what spectrum and waveform are now that we can see them visually on our canvas. So I just am doing console.log spectrum here, 1024 pieces to an array, and we know that it's array because of this open bracket and this closed bracket. And then we see numbers 101, 98, 72, right? This one has 106, 103, 82, 81. And so these numbers, 105, 101, these numbers are changing over time because of the frequency input that is coming in from the mic. So each of these, little spots here are being represented by the rectangles that we see. So if we come down and we look at what we did with this spectrum function here, we're using spectrum for the fill, and we are using it for the rectangle height. So essentially, if 105 is, it either goes low to high or high to low. I don't know. But the red bands are going to be the zeros down here. And then the 105 is sort of like more closer to the blue or the green frequencies at the edge of the canvas here. So just, you know, keep that in mind. That's where the numbers here are directly related to like this here. So you can use that to transform your sketches and understand how to use FFT. And waveform here, I now realize why we're using these mapping numbers -1 to 1, because if you if you console log waveform and then you open up the brackets or whatever, you can see these negative numbers. I'm assuming they go negative, and then we've got 0 here. So the range for waveform would be -1 to 1. And then if we just look over, and I'm describing this poorly because I'm not like, this is the first time I've ever really looked into waveform, so, but I'll do my best here for y'all. If you look over here at the wave, it's measuring amplitude. So if you like talk really loudly, then you can see that the waveform jumps up, and it's also measuring frequencies. So if it's like you have like a bunch of different frequencies, then you're gonna see a bunch of different like peaks in the waveform, and then if the amplitude change is, you'll also see that change. If you have like a monotone frequency, then the waveform is going to look just straight, like it'll be like a very like subtle buzzing effect, but multiple frequencies will cause all of those jumps and those waves to form. Okay, so hopefully that's a good enough explanation for you to then go and use these variables to create a sketch. So maybe using the music, like at this point, if you've got something in your sketch, you can test the music that we will be listening to, that Chris's class is going to be playing during the Audio Pixel Collider. So I'm gonna stop the video here since we've covered amplitude and frequency and ratios and all sorts of, and sliders and all sorts of stuff. And then the next video is also going to be important because I'm going to cover creating, using set time out to create a timer so that you can create a visualization that changes over time, because this has to be like 1 to 3 minutes around that amount of time, and we don't want to be staring at the same thing the whole time, right? We want it to change. So in the next video, I will go over that, and we can look at some other options out there for our visualizations.